For introduction, a centrifugal pump is a type of mechanical pump that transfers fluids by transforming rotational energy, usually from an engine or electric motor, into kinetic energy within the fluid. The impeller, a revolving portion with curved blades, is used by the pump to energize the fluid and include flow. Fluid is drawn into the center of the spinning impeller and then rapidly propelled outward. The continuous suction effect created by these outward flows create a low pressure area at the center of the impeller, which draws additional fluid into the pump. Centrifugal pumps are widely used in many different industries, including industry, agriculture, and water supply, because of its ease of use, efficiency, and adaptability in handling a variety of liquids.
So now I will be explaining the components of centrifugal pumps. The first component that I will be explaining is the casing. What is casing? Casing is a stationary component that surrounds the impeller and directs the flow of fluids. Either a diffuser or a volute style is possible. So what is impeller? Impeller is a revolving element that give the fluid more energy and quickens its speed. So the next component of the centrifugal pump is shaft. So what is shaft? Shaft is a component that links the impeller to the motor or the drive. And the components that will protect the shaft from wear and corrosion is called shaft sleeve. The next component that I will be explaining is bearings. Bearings is a component that support the shaft and reduce the friction. And the last components of the centrifugal pump is sealing arrangement. What is sealing arrangement? Sealing arrangement is a pipe that keeps fluid from leaking down the shaft. So it could be a mechanical seals or a fillings bulb.
The basic principle of operation of centrifugal pumps is force vortex flow. This means when a body of liquid is opened by an external torque, it increases the pressure of the rotating liquid. This increase in pressure is directly proportional to the velocity of the liquid. Thus, the rise in pressure is higher at the impeller outlet, causing the liquid to discharge at high pressure at the outlet. Because of this high pressure, the displaced liquid is lifted to high heights in the centrifugal pump system. Centrifugal pump working principle. Liquid enters the pump casing at the impeller eye. Velocity energy is imparted to the liquid by means of the centrifugal force produced by rotation of the impeller, and the liquid is radially pushed out towards the impeller periphery. The velocity energy of liquid is converted to pressure energy by directing it to an expanding volute designed casing in a volute type centrifugal pump or diffuser in a turbine pump.
There are 4 applications in various industry. First, food industry. Next, agriculture industry. Third, textile industry. And lastly, pulp and paper industry. For food industry, we have sugar refining. Centrifugal pump can be used for transferring liquid in the sugar refining process, where sugar solution need to be moved between different stages of the refining process. For bleaching and disinfecting, this pump may be employed in process involving the bleaching and disinfecting of food product. Next, for agriculture industry, we have fertilizer, fungicide and insecticide manufacturing. This pump can be used in the production of agriculture chemicals, facilitating the transfer of liquid during the manufacturing process. Centrifugal pump play a role in the textile industry by aiding in the circulation and transfer of bleaching agents during fabric and silk bleaching process. And lastly, for pulp and paper industry, we have bleaching pump. Centrifugal pump are employed in the paper manufacturing process for the circulation and transfer of chemical used in pulp bleaching, and for fireproofing and wood preserving in process involving in the treatment of wood for fireproofing and preservation. This pump may be used for liquid transfer.
Next, we will talk about the advantages and disadvantages of centrifugal pump. So first, the advantages of centrifugal pump is they are very simple design compared to the other types of pumps. They consist of a few case components such as an impeller and a casing, making them easy to manufacture, install and maintain. So, second is The pumps are very known for their ability to provide high performance in terms of flow rate and pressure. They can handle a wide range of flow rates and are often used in applications requiring moderate to high pressure. Centrifugal pump also can be used in applications that require transportation of fluid that contains impurities because of their design that allows for the passage of particles. However, the extent to which they can handle impurities depends on factors such as the impeller design and the size of the particles. They also perform well under constant heavy loads and challenging conditions. They can handle continuous operation and are commonly used in industrial settings where a constant fluid flow is required. Lastly, centrifugal pumps also cost-effective for high-volume applications due to their efficient fluid movement, simple design, and ease of manufacturing. Their ability to handle large flow rates makes them well suited for situations requiring the transportation of significant fluid volumes. Next, we will talk about the disadvantages of centrifugal pump. First thing first, centrifugal pumps are less efficient with high viscosity fluids, leading to reduced flow rates, lower head pressure, and increased power consumption. Careful pump selection is required for applications involving viscous fluids. Centrifugal pump also may become expensive for high-pressure applications requiring additional equipment like booster pumps or multi-stage pumps. These can lead to higher capital and operational expenses. They often require experienced control systems for monitoring and optimizing performance. Skilled operators are essential to interpret data, make adjustments, and troubleshoot issues to ensure efficient pump operation. Lastly, centrifugal pumps are sensitive to changes in system conditions, such as variations in flow rate and pressure. Operating a pump away from its design point can lead to reduced efficiency and increased wear and tear.